Welcome to Engineering Funda family. This video is a part of Network Theory lecture series, and in this video I'll be going to explain you average power calculation for AC signal. So before I explain you two very interesting examples based on how we can have average power calculation based on AC signal, let me explain you the basic formulas which is associated with calculation of average power. So before we see average power formulas, I would like to explain you formulas based on energy calculation, as power formulas are based on energy formulas, right? And in next video I'll explain you two interesting examples based on calculation of energy which will be based on waveforms, right? So let us see first the basic formulas. So when we talk about energy calculation, then in calculation of energy is power into time, right? But here if time is variable, then you can have calculation of energy by integrating power with respect to time. Now see, power that can be there in terms of voltage and current. So there can be multiple formulas, like you can have power as per P is equals to V into I dt, or you can have power in terms of I square R dt, or you can have power in terms of V square by R dt, right? Now if you see this formula, which is integration of voltage into current into time, then as we know that this current, that is dq by dt. So if you substitute that, then dq by dt and into integration dt is there. So this dt will get cancelled, and you can have one more energy formula based on voltage integration over charge, right? So there are multiple formulas which is there with energy calculation, which is what? Integration of power over time. Now when you want to solve power, then average power, that will be energy over one period of cycle divided by that period. So energy over one period, that we can identify as per integration of power with respect to time, where time is having one period 0 to t, and divided by that period, that will be average power, right? Now many of the times this power that may be given to you in terms of current, or it may be given to you in terms of voltage, right? So if it is given in terms of current, then you will be having I square of t into R dt divided by period t. And if it is given in terms of voltage, then you will be given in that way V square t divided by R of dt divided by period, where this time that is ranging from 0 to t, right? Now you see here, integration of I square t dt over 0 to t divided by t, that is I RMS value. So you can say that I RMS square into R, that is what average power, as well as you see here integration V square t dt over 0 to t divided by t, that is V RMS square. So you can say that average power is V RMS square divided by R. So these are the basic formulas that you should remember to have a calculation of average power, right? Now I'll explain you how to apply these formulas. So for that, let us have first interesting question. So here you can observe we have been given with very simple circuit in which voltage V of t, that is connected with 10 ohm resistor, and that is flowing current I of t. And here waveform is given for current I of t, which is varying with respect to time. So now what we need to do is we need to find average power delivered to the resistance which is shown in this figure. So as if you want to find average power, then simply as I have explained, average power, that is IRMS square into resistance R, and you should know how to calculate IRMS. See, I am taking R over this side, and IRMS square, that is 1 by T integration 0 to T I of T whole square dt, right? That is how we can identify the value of IRMS. So here now our agenda is to find what is I of T. Now if you see here, I of T, that is repeating after every 1 second, you see, right? So based on this waveform, I can say that this time period, that is T is equals to 1 second, and I of T, that is ramp signal, right? And this I of T, that is having slope, that is y divided by x. Y is 10 and x is 1. So slope is 10. So I can say that this ramp signal is slope into t, that is 10t. So now I got the function which is I of T, that is 10t. I can place that in this formula where t is 1 second, and here you see resistance R, that is of 10 ohm. So 10 into t is 1 second, so 1 by 1 integration 0 to 1 I of T square, that will be 10t square dt. Now you see this 10 that we have, and this 10 square, that will be 100. So 100 into 10, that is 1000, and you see integration of t square, that is t cube divided by 3, and limit is there from 0 to 1. Now if you substitute limit, then when you place 1 at the time, it will be 1 by 3. When you place 0 at the time, it is 0. So 1 by 3 minus 0, that is 1 by 3. So this average power, that will be 1000 divided by 3, or you can say that that is 333.33 watt. So my dear students, all you need to do is you will have to identify the function which is given in terms of waveform, right? And you will have to see over how much time period that signal is getting repeated. So you will be having the value of t, and you will be having the function, and then simply you just have to do integration for IRMS or VRMS. IRMS square, that is 1 by t integration 0 to t I square t dt, and VRMS square, that is 1 by t integration 0 to t V square t dt, right? And average power is how much? IRMS square into R, or it can be VRMS square divided by R. That is how we can find average power. Let me give you one more example, so that will resolve your understanding further. So here you can observe we have again same circuit with voltage Vt and current It, but here graph of Vt with respect to t, that is given. So now we need to see what is this function Vt, right? And if you observe that this Vt, that is getting repeated after this much amount of time period, that is t is equal to 2 seconds, right? It is getting repeated after every 2 seconds. Now what is this function? So if you see for 0 to 1 second, this Vt, that is ramp signal, and its slope is change in y divided by change in x. So that is 10 by 1. So that will be 10 into time period t. So that is Vt for 0 to 1. And if you see for 1 to 2 second, this function Vt, that is minus pi, which is constant, right? So I can say that now based on this, our Vt, that is 10t in between 0 to 1, and our Vt, that is minus pi in between 1 to 2, right? Now to calculate average power, all we need to do is we need to find, see that based on voltage, so it will be Vrms square divided by R, and you see value of R, that is 10, and VRMS, that will be 1 by T integration 0 to T V square T dt. Right. Now substitute the values. So 1 by R is 10. So 1 by 10 time period, that is 2 seconds, you see. So I am saying this is 1 by 2, and now you see this integration that will get bisected into two limits. For 0 to 1 it is 10t, and for 1 to 2 it is minus 5. So here I am integrating that over 0 to 1, where v square t, that is 10t whole square dt, plus integration from 1 to 2, now it is minus 5 square dt. Right. Now we just need to solve this. So this is 1 by 20, and you see this 10 square, that is 100, that will come out, and integration of t square, that is t cube by 3, limit is from 0 to 1, plus this minus 5 square, that will be 25, and integration of 1, that is t only, with limit 1 to 2. Now just substitute the limits and you will be having the exact value. So 1 by 20, and this will be 100 into 1 by 3, as when you substitute 1 it will be 1 by 3, and when you substitute 0 at the time it will be 0. So this will be 100 divided by 3, and you see for this when you substitute limit 2 at the time 2 minus 1, so that will be 1 into 25, so plus 25. So you just solve this and write your answer into the comment box. Right. I hope you have understood this. Still, if you have any confusion, you just write down your confusion into the comment box. Definitely I'll get back to you, and based on that I'll try to solve your queries. Thank you so much for watching this video.